Hello everyone, welcome to another edition of the Hot Seat. I'm Tim Doiron, Principal Analyst of Intelligent Networking at ACG Research. Joining me today is Joe Mocerino, Principal Solutions Architect at Fujitsu. Our topic today is CRAN architectures and the migration from service providers to those architectures and mobile front haul. Welcome to the Hot Seat, Joe.
Well, thank you, Tim. Glad to be here.
Okay, so let's jump right in, Joe, with the first question, and that is, what is a CRAN architecture and how does mobile front haul fit into it?
CRAN architecture is essentially an evolution from a DRAN architecture, a DRAN being a distributed RAN, a CRAN in today's technology being a centralized RAN. And ultimately, we'll see not cloud RAN, another part of C, but cloud-based.
Got it. And so with the DRAN architecture, we had something like I think we used to call it an eNode B, and it had both the remote radio and the electronics. Are we busting those pieces apart, and is that where front haul fits in?
That's exactly it. The eNode B consists of these two pieces, the baseband unit and radio head. And when we take that baseband unit and remove it from the macro site, centralize it at a location, which we'll refer to as a BBU hotel, this is centralization, and this is where we have centralized RAN applications.
Gotcha. And then the connection between the radio and what I think you're calling the BBU or the BBU hotel, that's where our mobile front haul fits in. Is that right?
That's exactly it. That connection is using the CPRI protocol that was designed specifically for this type of application, but originally in the DRAN, this was co-located all at the cell site. In the CRAN, or centralized RAN, it's now at a distance that is defined by the radio at this central location.
Gotcha. So with the CRAN architecture, what are some of the benefits that service providers are trying to achieve, and really why are they moving in that direction?
They're moving to a CRAN, centralized RAN application or technology architecture, because there is a major cost savings in doing this, as well as a performance enhancement, just by rearranging their network from distributed to centralized.
Gotcha.
The cost enhancement is achieved through CapEx and OpEx. In CapEx, you have multiple baseband units that are centralized at a location. They can operate as a pool of processing power.
Okay.
In that way, you can engineer your network to optimum performance, as opposed to in a DRAN, you engineer individual cell sites.
Gotcha.
Not your network, which is what you do in a CRAN,
right,
through BBU pooling. Also, you have a performance enhancement. Through that centralized BBU application, you can then have cell site aggregation. And this is where multiple cell towers can communicate with a mobile handset at an instant in time, whereas in a DRAN, you only have one mobile cell tower that is communicating with a handset at an instant in time. Having that cell site aggregation gives you the ability to have a performance enhancement that can be up to 30% better than what you had before in the DRAN.
So Joe, Fujitsu is a company well known for front haul and back haul and optical and Ethernet solutions. Can you tell us about your smart xHaul solution and what makes that product different?
Fujitsu's smart xHaul solution is an intelligent WDM system for front haul, back haul. It addresses all of these applications. The most significant differentiator with our smart xHaul solution is that it can read and diagnose, do performance monitoring, distinguish between radio signals and optical signals. So that if there is some type of remote impact to the network operations center will receive that information that there's been a performance impact, and will be able to diagnose, was it a radio failure, was it an optical failure? With our system, because it can distinguish between radio and optical failures, if you do have to dispatch a technician out, you're going to dispatch the right technician the first time.
Yeah, I can see why service providers would really like that, from a quality of experience, from a total cost of ownership, and the rest. So let's go down the kind of evolution of the smart xHaul product for just a minute, which is there's a number of things happening which we've already touched on in this in our discussion here today. There's the road to 5G. There's virtualization, and in that cord or the re-architecture of a central office. How do you see all of those things combined with we're trying to build programmable or programmatic interfaces and programmable networks? How do you see that impacting the future of the smart xHaul product and products like it into the future?
Well, you'll see a lot of evolution in terms of the technology, where some will be virtualized. Other parts, the actual fiber optic signals, they're still physical signals. There'll still be transponders that operate over those fiber optic facilities. And going, for example, from 4G to 5G, different type of transponder, different type of technology. Today we use CPRI technology or CPRI protocols to interconnect those baseband units to the remote radio heads or hotel centralized location to the macro sites. But in the future, as we roll in 5G, CPRI is very inefficient. And using CPRI in 5G would result in 200 gigabit per second interfaces. That's actually at the starting point. It can go even much higher than that, which is really price prohibitive, especially in an access network. Having different types of functional splits between the BBU and the RH, where today all the functionality, all the processing is being done in the BBU. In the future, with 5G, because of the significantly higher performance, you would split that processing up between the two. So some processing in the BBU, some processing in the remote radio head. And by splitting up that processing, you reduce the amount of transmission that's required. And it can go down as low as 12 gigabits per second, maybe as high as around 50 or so gigabits per second. But now you're starting to get into a much more workable state for these higher performance applications that 5G will address.
Well, Joe, that's a wrap for the Hot Seat. Thanks for coming on and being with us today and sharing your views and your perspectives. I really appreciate it.
Great.
And thanks to all of you for watching another edition of the Hot Seat. We'll see you soon.